Good day, everyone. My name is Mark Fonda, and I'm the Chief Technology Officer for Meridian Energy Group in Houston, Texas. This presentation is entitled Digital Technology for the Modern Grassroots Refinery. My background is refinery technical services, including process engineering, project development, and project management. In 40 plus years in the industry, I've worked for Mobil, Ultramar, Hess, Coastal, and Sunoco in staff positions in 6 different refineries. I've been with Meridian for 3 years now, and we're developing a new approach to refining, which is modernized, efficient, flexible, technologically advanced, and smart. Meridian is designing and building a series of small, conventional, state-of-the-art refineries, and we have a vision for applying digital technology. We have presented much of our company plans and project developments in previous presentations and articles, which can be found at meridianenergygroupinc.com. I would like to outline our basic strategy to utilize digital technology to help achieve our project and operational goals. We believe that our facilities and the entire downstream industry can become cleaner, safer, and smarter. This discussion will be very general based on research we have done over the last couple of years, and I won't cover any specific brands or vendors. Here's an interesting quote, which I think characterizes one of our goals by the CIO of one of the hotel chains. It's no longer the big beating the small, but the fast beating the slow. We believe the approach of being quick and agile in response to market conditions or in resolving operational issues will be a huge advantage. This agility could be in the form of early adoption, being a first mover, or the ongoing ability to seize opportunities quickly. A small, fully digitized plant can compete with a much larger, more conventional plant, which relies on economy of scale. So what is a smart refinery? I wish to provide an overview for applying currently available digital technology to a grassroots refinery, a smart refinery. For us, this is not a transformation, but a foundation starting from the ground level. This can also provide a blueprint for transforming the downstream industry, as we have studied other industries such as mining, transportation, and upstream oil and gas. So some ground rules or assumptions we make are that we want to design the facility from the ground up with no external constraints such as corporate standards or pre-existing partnerships, truly a clean sheet of paper. We want to provide a cutting edge and also proven technology basis. We don't want to be a testing ground and the system must run reliably from day one. This applies to our process technology, our environmental technology, and our digital technology. With a rapidly evolving marketplace for digital technology, we want to make purchase decisions late in a cycle. This introduces a challenge to identify latecomers and get them tested or to complete due diligence. Our goals are to achieve maximum efficiency and capability within typical project capital constraints and schedule. The facility should be decentralized and autonomous, yet able to collaborate widely. We want to provide data availability outside the plant, but still maintain complete cybersecurity. All systems must be tested and running prior to plant commissioning, with all personnel adequately trained. This will be integrated into our operational readiness program for procedural development and training. Some of the benefits we expect to achieve are lower EPC project cost due to more efficient project execution, such as data handover, less backtracking, etc. Faster EPC completion, leading to earlier operational profits. Better refinery operating efficiency, such as equipment availability, energy, yields, quality, etc. Better equipment reliability, providing lower OPEX. Reduced unscheduled downtime from equipment failures, and reduced future capital spending from more efficient use of capital. The expected payout is between 1% and 3% of our TIC, total installed cost, for project savings and early startup, which is items 1 and 2, and about the same, 1 to 3% for ongoing annual savings, which is items 3 through 6. So for a $1 billion project, this amounts to upfront savings of between $10 million and $30 million, and about the same savings every year thereafter during operations. Based on this, a budget for enhanced digital technology can be established, but most of this is just standard equipment for any new project. Intangible benefits are expected in regulatory compliance, community relations, and plant morale. The methodology or process by which this is achieved is to provide a foundation utilizing specialized hardware, software, and infrastructure for basic process operations, build higher level layers of data management to provide advanced process control, plant-wide data integration, ERP interface, and advanced analytics. Provide remote monitoring capability to reduce on-site manpower needs, collaborate with business partners, and to integrate multiple facilities. Provide initial and ongoing training for operations, maintenance, technical, and any personnel involved in daily operations. Altogether, this provides the means to optimize the plant, our supply chain, offtake partners, and to integrate it all together. Here's a checklist of network components. This is to provide state-of-the-art equipment for the network architecture. The first 3 categories are mostly field hardware and software, the control systems, safety and compliance, and communications. These are the backbone of the information system, and it all has enhanced capabilities to interact up and down the line. The remaining 2 categories are data processing and analytical systems, data collection and analysis, and digital twins. These are typically implemented over time in a piecemeal fashion, but the key with a smart refinery is to implement this all together, integrated and optimized from the start. Some of the key smart components are to have robust field instrumentation with automated marshaling, self-diagnostics, and virtual reality. Particular attention should be paid to the ER provider and the integrator for capabilities, compatibility, and flexibility. Digital twins for design validation, operator training and troubleshooting, and engineering analysis. These are dynamic process models operating in real time, covering the full plant, and are all integrated together. They provide a comparison of actual performance versus expected performance, and they can spot discrepancies in order to pinpoint issues and stay ahead of trends. Things that used to take days or weeks to analyze are now done instantaneously. When applied consistently and thoroughly across the plant, the result is real-time optimization. Then on top of all that is machine learning or artificial intelligence for additional layers of analysis and forecasting. We can't do this without gathering information for some time to build a database. Data is cascaded into higher levels of analysis, allowing for more sophisticated trends and forecasting. This can eventually become autonomous or closed loop once there is validation over time and confidence is established. In the short term, it would be advisory and manually implemented. So for validation, once we start operating, in order to measure the effectiveness of digital technology and the full project, we need to provide metrics or key process indicators to track and communicate performance targets to all levels of plant personnel and active business partners. These will allow us to focus on what is important, aligning all of our departments and shifts to a common objective, and to provide transparency and accountability for regulatory compliance. We want to be an industry leader in HSE and ESG performance, something which Meridian has strived to do from the beginning. And eventually, the Solomon Refining Industry Benchmarking Study, we would like to achieve first quartile performance from the start in process performance, equipment reliability, operating costs, and profit margin. And lastly, sustainability. We want to ensure that the project and the plant remain sustainable. There must be an ongoing effort to maintain compatibility with industry standards and equipment designs, with particular attention to usability, training, and implementation. There must be a plan for future incremental upgradability or to be future-proof. For example, greater use of handheld devices, use of virtual reality to troubleshoot, or even wearable devices to monitor health of employees. And always continue to learn and enhance the use of digital technology as new products develop and become available and commonplace. The curve is steep and we need to stay on the forefront. Another interesting quote, this one, an older one from Charles Darwin. It is not the strongest of the species that survives, nor the most intelligent. It is the one that is the most adaptable to change. So the downstream industry is being challenged with demand disruptions, environmental and social initiatives, and changing governmental mandates. The facilities that survive will need to adapt in many ways, and digital technology may be the most important of all the tools available. In total, we believe that a Grassroots refinery can utilize available, proven technology to ensure superior performance for the entire plant lifespan. Any new plant or significant upgrade or expansion of an existing plant must utilize digital technology in its entirety in order to adapt, survive, and thrive. So thank you for your attention. I'll be available for some questions, or you can look at our website, meridianenergygroupinc.com, and that's my email address there also. Thank you very much.
Mark, thank you very much for that. That was very, very good. I have to admit, I was transfixed with a couple of things there. I'm obviously very interested about anything digital twin at the moment, so it was good to sort of see that reference point. I like the way you started it. What is it? It's not the big beat in the small, it's the fast beat in the slow. So I like sort of the way in which you went into the presentation, which is excellent. Can I ask you, as a sort of starting point, what is the status of your current project at the moment, Mark?
Yes, thanks for asking that. Meridian's Grassroots full conversion refinery in North Dakota has completed basic design and over 2 years ago received its permit to construct from the state of North Dakota Department of Environmental Quality. Federal EPA approval was not required since the facility is a synthetic minor source and it meets all applicable environmental standards on the state and federal level, including Class 1 air quality by virtue of being close to a national park. This was the first air permit granted to a full conversion refinery in the US in over 40 years, the first ever as a synthetic minor source, and the first ever to meet Class 1 air quality. However, the project was delayed due to litigation and then the COVID pandemic. Environmental groups mounted lawsuits to block construction, and 2 cases made it up to the North Dakota Supreme Court late last year. Fortunately, the court ruled in favor of Meridian in both cases on the merits of our air permit technical assessment and the facility jurisdiction. The project is now clear of any legal hurdles and will be completing FEED in the coming months. We're now expecting completion of detailed design, construction, and startup in 2024. We plan to build similar refineries in Texas and Oklahoma, both capitalizing on light sweet crude from fracking and a decentralized business model. So the North Dakota refinery is our template going forward.
Okay, that's very good to hear, Mark. And how, in your opinion, because obviously this event is dealing with digital and the link also between that and decarbonisation. And obviously you've got another area of ESG compliance. So how does digital technology fit in with the ESG compliance from your side?
Well, in case you're not familiar, ESG is environmental, social, and corporate governance. It's all the rage in the investing community right now. And in compliance with the prevailing standards for responsible investment and growing trend toward decarbonization, We feel that digital technology is an invaluable tool for ensuring accurate technical design, enhanced operational efficiency, assured regulatory compliance, and conditional forecasting for sustainability. Our projects were conceived and will be executed in this new regime, and ESG is part of our company DNA, and we see things such as KPI tracking with external transparency as a vital service to the local community and to the industry as a whole.
So what can a refinery do to become smarter?
Well, we can assume that most facilities these days are fully digitized, such that real-time data is collected and shared. Otherwise, its days are numbered. And there are a few older refineries dropping away. I think that most refineries have, digital technology implemented to some extent, and most of them have advanced process control, economic optimization through an LP, and computerized maintenance programs. They probably also have offline process models of most process units and utilities. But what they probably don't have is digital twins to track the operation in real time, and then a higher level integration and optimization of the whole plant, including external logistics. So there are many systems available now and for providing all these tools, but it's a daunting task for any older facility. So we feel that's one of the advantages we have over the older refineries, which may not be able to make the leap. Those that do will become part of a transition into the new energy supply landscape.
That's a good point. I think it also leads into change management and cultural change within an existing framework. How do you get people to buy into this? Because obviously, employers need to buy into acceptance and compliance. So what type of strategy are you using to sort of facilitate that within Meridian?
Well, the industries with the most recent investment have benefited from the use of digital technology, which includes transportation, mining, and upstream and midstream oil and gas. We feel that downstream oil and gas has been burdened with changing regulatory requirements and huge market swings. And at least in the US, most investment has been for compliance and minor upgrades or expansions, not grassroots facilities. So we borrowed some ideas from these industries, such as remote operating center, logistics integration, and wireless instruments. Also, the extra intelligence that comes with digital twins, machine learning, and adaptive maintenance will take it to the next level.
Can we, because we referenced this earlier in the day about cross-sector or cross-industry, and how technology is being used across the board. So you use it in different sectors. What features of, let's say, digital technology from other industries are available to downstream?
Well, as I mentioned, a remote operating center, we plan on capitalizing on that. Our refinery is going to be remote in, they're placed to be near shale oil production. So our first is going to be in North Dakota, second one in West Texas, and the third one probably in Oklahoma. So it's best to concentrate our manpower in our corporate headquarters of Houston. So we're going to have the remote operating center that will mirror all the operations in the remote facilities, and we'll have another level of engineering analysis and economic optimization done from the corporate side. We'll have people on the ground, but we'll probably have a different ratio of in the field versus corporate headquarters. So that's one of the big things, and and then digital twins, of course, is the big thing. When I was a young engineer, I could do an exchanger survey. It might take me a day or two to collect data, day or two to analyze it, and then another day or two to get it out into the field. Well, that's done instantaneously now with digital twins. So comparing actual versus expected performance is done wholesale across every single process unit. And then we can compare the sum of all that to optimize the plant also in real time. So that's a huge game changer.
Mm. I think there's one question, because I've been asked a few questions to put forward to you, but there's one last question that I'd like to put forward to you. With everything that's taking place, obviously we heard a lot today and also yesterday about how technology and innovation is positively or potentially can positively affect your carbon footprint. Do you see that accelerating a bit? Because obviously we heard about digital twin yesterday and how it reduces your carbon footprint, less, more efficiency, less downtime. So do you think that's going to be accelerating more? The more there's a link between that, do you see sort of that landscape expanding drastically in the next few months?
Well, yeah, decarbonization is huge these days. We plan on being a transition technology or transition facility within Downstream.
Mm.
The efficiency of our plant is incredible. We have less than half of the greenhouse gas emissions per barrel than the average U.S. refinery.
Oh,
And
wow.
the way that's done is through selection of process technology, and also being able to run a single crude for the life of the project. We don't have to build in a lot of extra capacity for changing yields. Most refineries are on